In learning objectives E and F, we're going to talk about complement of an event and find probabilities using complements. So complementary events there are two events that are mutually exclusive, and their union is the entire sample space. So a really good thing that's complements of each other is one group of boys and another group of girls. They're two different groups, but all together they make up everybody. What we say if we want to find the complement of event A, it is called not A. And the formula we can use to find the probability given a certain event, and we're going to again call this event A. So the probability of not finding A is equal to 1 minus the probability of finding A. So let me give you an example. What if event A was randomly selecting a boy from a group? So then the question would be, what's the probability of not selecting a boy? Well, the probability of not selecting a boy is basically selecting a girl, so that's its complement. If we don't want to sit and have to count all the girls, what we could do is just take 1 minus the probability of finding the boys. So if it's easier to find all the boys and subtract it from the whole, you can do that to find not boys. Or if you want to find not the boy, you would just count up all the girls and find the true complement of it. Now, here's 3 different events we want to talk about and talk about their complements. So this first one, if we toss a coin, our sample space is heads or tails. If the event is considered tails, what's the complement of tails? Well, the complement's either not tails, or in this case, we would say it is getting heads. Okay, what if we are looking at tossing 2 coins? That sample space has 4 different outcomes, double heads, double tails, and a heads-tails combo. If the event is considered getting no heads, which is TT, so basically the event is getting 2 tails, what's its complement? Well, the complement would be not getting TT. In this case, its complement would be the HH, the HT, and the TH. The last one, we're picking an integer from 1 to 100. Our sample space are all the numbers 1 through 100 that are integers. The event is picking a prime number. The complement of picking a prime number is not picking a prime number. Now let's refer back to those 298 students that were speaking French and Spanish, and they want us to do here. If a student is selected at random, what's the probability that he is not studying both the languages at the same time? So the question is, what's the probability he's not French and Spanish? Well, an easy way to find that is you can actually do the probability of 1 minus the probability that he does speak French and Spanish. Well, we already figured out what's the probability they speak both French and Spanish. Well, that was 26 out of 298. So if you take 1 minus that, you're going to end up getting 272 over 298. So if you know this combined probability here, it's almost easier to use the complement to find those that don't speak both French and Spanish. So let's look at another one. Question is, if 3 fair coins are tossed, what's the probability not all the coins show the same face? So maybe you want to figure out what the sample space looks like. We have 3 coins, 2 outcomes on each. That means there's 8 in this. And let me actually jot down the sample space first. So here's what all of them look like. Again, the question is this: what is the probability not all the coins show the same face? So I'm going to put probability not all same face. Well, to find that, what I could do is do 1 minus the probability they are all the same face. And if we do that, we would just look at it and say that's 1 minus probability they all the same face. There's 2 of them, so 2 out of 8. You subtract that, we're going to get 6 out of 8, or 3/4. Now, let me show you that you don't have to do the complement of it. You could just read it directly from this. The probability that it's not all the same face, if you go in and look at it, that they're not all the same face, it would be this, 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 and the last 3. So if you went that way, you would say it's 6 out of 8, and you'll still get the same answer. So complements aren't necessarily required to be done, but sometimes they just make things easier. In doing this calculation over here, it was actually easier because we only had 2 scenarios that we had to count and then subtracted from 1.